How you guys doing? This is 2010 Form A, number 6. Let's do it. So let me highlight. So we have a differential equation. So they give you the first derivative and the second derivative. Wow, that's really bright. And they give you a particular solution right there. Let me lighten that, We'll just stay with it. So we want the equation of a tangent line. Once you read let me get it pink. Once you read equation of a tangent line, immediately you should think this. So I need x1, y1, which is any point, but we're told x equals 1, so it must go through that point. And we know from here that the y value is 2. So we know we have 1, 2 is a point that it goes through. And now we have to find the slope. And the slope of a tangent line, y'all should know this, it's the derivative. Gives you the slope of the tangent line. So we need the derivative at the point of tangency. So you're just going to plug 1, 2 into the derivative. So we're going to get 1 times 2 cubed. And this comes out to be 8. So we're pretty much done. Our y1 we know is 2. Our slope is 8. Bam. Parte finito. Let's go to part B. I'm going to do that by coloring over all this. All right, part B. Oh no, I erased my equation. I think I remember. So our equation we had from the previous one is y minus 2, 8, x minus 1. So if you just solve for y, we're going to get 8x minus 8 plus 2 is minus 6. So f at 1.1 is about our function evaluated, our tangent line evaluate 1.1. So it's 8 times 1.1 minus 6. Done. Finished. We don't have to go any further than that. If you want to simplify that, you may. But now we have to answer the second part to this question. Actually looking for a paper right now. Let's see it. All right, so that is our approximation. That's what, 8.8 minus 6, so 2.8. Now again, you shouldn't simplify that far, but if you did, there's your answer. Now if you want to know the approximation is greater than or less than, so this is actually your justification. You need to know, let me do a different color, blue. Its concavity determines the tangent line above or below. If you have a concave up or concave down, and you do a tangent line, any tangent line on a concave up graph is going to be under. Any tangent line for a concave down will be over. So we need the second derivative at the, okay, so the second derivative, not just at the point. We need, okay, let me explain this. Say we're estimating here in place of that. So we need it from the point of tangency to the point being estimated. We need this whole region to be either concave up or concave down. So let's evaluate the second derivative. Let me erase that and do it in a lighter color. So we know it's going to be from 1 to 1.1. Our x will always be positive, and our y, we have to make sure our y is always positive, which it is. Oh, dang, it's right here. I was trying to figure out how to prove y was positive. So those are the two facts that we have. So we can say since f of x is positive and x is between 1 and 1.1, d2y dx squared is going to be positive on the interval from 1 to 1.1. Since the second derivative is positive, that's going to give us a concave up situation, so our approximation is under. Therefore, the approximation, that's getting really sloppy. I'm going to use a thinner pen size. Oh my, that's ugly. That's bad. Bad. Let's try this again. Is less than f at 1.1. Bam. Okay, so that's part B. Let me color all this in. We're going to do part C. Part Z, we want to find a particular solution. In other words, they want to know what f of x is. We've got the derivative of f of x. We need to find the original function, but if you have the derivative, clearly we need to take the antiderivative. So that's the process we're going to take in this next step, except our function, let me erase all this. That will explain to you what we've got to do. All right. We have dy dx is xy cubed. Now, note, our function is y and our variable is x. We have our function y there. Whenever that happens in order, we just can't take the antiderivative directly. We need to do separation of variables. So your first point, divide both sides by y cubed, and then we get the dx on the other side. You should get a point for that step. Now the left side, it's not ln of y cubed. To do that, if you were trying to do ln of y cubed, you'd have to do a u sub, and then du would be 3y squared dx. There's no way you're going to get that here because you don't have that, so you can't do a u sub that way. Therefore, you're not going to end up with your ln of y cubed. You should recognize this as just rewriting. So you rewrite this as y to the negative 3 power. Now we can integrate both sides. So you add 1 to the exponent and divide by that. Same thing, add 1 to the exponent, divide by that, and we're going to add our constant. So we're going to find that constant. Let me rewrite this. It's going to be negative 1 over 2y squared. Now we know that 1, 2 is a solution. We know that 1, 2 must be a solution. So therefore, if we plug that in, oh yeah, that was ugly, huh? If we plug that in, get negative 1 over 2 times 2 squared, 1 squared over 2 plus c. That's going to be negative 1/8 and 1/2. Subtract 1/2 from both sides. Whoops, daisies. Get a common denominator. So c is going to be negative 5/8. We're going to take that and we're going to plug it in for c. So our goal is to get y by itself. So I'm going to multiply both sides by negative 2. That will do a couple things for us. The negatives will cancel. Let me get another color here. Blue looks good to me. The negatives will cancel and the 2's will cancel. I have to distribute those. So I get 1 over y squared equals negative x squared plus 5 over 4. Now we have to take the reciprocal of both sides. Now that's kind of ugly, but we can do some stuff to that. So we're going to have to square root both sides, and we're going to get a plus or a minus when we do that. But if you want to make this prettier, I would multiply both sides by 4 over 4. Multiply by 4 over 4, which is just 1. And we know we're allowed to multiply anything by 1. And it doesn't change it. So we're going to get minus 4x squared plus 5. And I can rewrite it in the bottom. Put the 5 first. It looks prettier. Then square root both sides. You get a plus or minus square root of 5 minus 4x squared. Now, is it plus or is it minus? We know that 1 comma 2 is a solution. So when you plug in 1, you have to get 2 as your answer. So when you plug that in, clearly it must be the positive one. So our final solution is the positive radical 4 over 5 minus 4x squared, which you can rewrite, but you don't have to, as this. And that's it. We're done with this problem.